Hi, everybody. So what you can see on the screen is a tool and somebody's chest. So tool, meet, chest. And now today we're going to talk about the Unofficial VCDX Toolchest. So a little bit about myself. My name is Irfan Ahmad. I am the Chief Technology Officer and the co-founder for a company called CloudPhysics. Today I'm going to be talking about not the usual tools that you hear about with tools that experts in the VMworld community are used to using. I think there are some tools that are neglected or once were popular or not popular right now that I think are quite useful. So I wanted to bring those back into our attention and go run through them. So the first one I'm going to talk about is RV Tools. Now, RV Tools is quite popular for a while, but somehow recently seeing people kind of move on and forget about it. So I want to bring attention back to Rob's RV Tools. Currently, it's at version 3.7. It's a completely indispensable tool. If you're not already using it, definitely check it out. And lots of cool enhancements in the last couple of years, lots of new reports have been added. Totally worthwhile. Next one I want to talk about is VCDX. So this is one of those tools that has been around a while. It started in 2006 was the first time that it became available in the ESX VM kernel. Back when I used to work at VMware, that was one of the tools that I wrote. And in 2007, in ESX 3.5, that actually became officially part of the distribution, and since then has been continuously available in the ESX product. The really cool thing about this tool and why I think it should be part of everybody's tool chest is that it gives you uniquely across all the various hypervisors that are available and across any other even non-hypervisor technology, it uniquely gives you the ability to see, to almost perceptually see the workload's shape. In particular, this VCDX tool is focused on the I/O workload shape. So this will work for your virtual disks that are being run on top of your SCSI, your iSCSI, your NFS data store. So it's not particularly concerned with what the underlying type of storage that is hosting the virtual disk. So when I say you can almost perceptually see and feel the workload shape, well, first of all, let's talk about why that is important. Now, we all know that if you were to take a single disk, just a spinning disk, and run a completely random workload on it. So let's say a 1 terabyte disk, and you run a random workload on it, you'll get some amount of throughput. My guess is for most disks today, even the 15,000 RPM disks, your random workload throughput, random read throughput, would be somewhere around maybe 2 to 5 megabytes per second, depending upon what type of the 1 terabyte drive is. If you go into the really, really fast drives that are more dense, you might be able to get a little bit higher. Now try the same disk, but with a sequential workload. What do you think the throughput would be? Depending on disk, it could go from 100 to 150 megabytes per second. So think of that as a 10x difference. In the worst case, and in the best case, a 100x difference between the throughput of a very simple workload, sequential versus random, right? Now, do you know that noisy virtual machine that is in your environment that always causes you problems? Do you know what workload it's running? And majority of us don't, because we don't have a way to know if it's sequential or random. When that client calls you up and says, hey, my VM is running slow and it's because of your disk, VMware is a problem, or the SAN is a problem. Well, how are you supposed to debug that when you don't even know what the performance should be? Because the performance should perhaps be 1 megabytes per second, actually, or maybe it should be 150 megabytes per second, and you're seeing that big a difference. So how are you supposed to know? So that's just on sequentiality versus randomness, right? Now let's talk about a couple of the other characteristics. Right? Let's talk about I/O block size. Now, if someone is running this is very common. We see this at CloudPhysics. We see this with almost every customer. What will happen is if you measure I/O latency as just normally measured, you will see that latency at least once or twice in the day will spike up to 100, 200 milliseconds per I/O. People freak out. Alarms go off. Right? This is one of the reasons why people turn storage I/O performance alarms off, is because once in a while, for a few minutes a day, that latency gets up to 100 or more milliseconds per I/O. Well, if you don't know what the block size was at that point in time, how are you supposed to know if that's normal or not? And in particular, backup workloads they issue very, very large IOs, as they should. They're trying to back up big chunks of data, so they'll issue 256 kilobytes, maybe 512 kilobytes, and in some cases, 1 megabyte IOs. Now, a 1 megabyte IO is clearly going to have more latency associated with it than a 4 kilobyte IO, right? So is the latency because the disk is slow, or is the latency because the workload had changed? It's not clear. So when that client calls you up and says, hey, my VM is very slow at a certain point in time in the day, and you're looking through the stats and you're seeing high latency, and all of a sudden you're saying, hey, I need to buy a new storage array, or I need to buy caching, or I need to do X, Y, and Z. Well, you didn't know if it was sequential or random, which would have given you a clue about whether or not the performance and the latency that was being seen was expected. Right? You didn't know what the block size was, which would have told you whether, what latency you should have expected, because a large 1 megabyte IO is going to have a very long latency. Right? So here are a couple of examples of things that you just are not aware of unless you use VSCSI stats. Right? So the other really amazing thing about VSCSI stats is shown in the plot on the left here. So the leftmost plot here kind of looks like a weird teardrop, right? So that is showing the latency distribution. So let's talk about that for a second. So what that's saying is that the x-axis there, so how wide at a particular point that violin plot is, shows you what percentage of the IOs were of that latency. So on the y-axis you see latency anywhere from 100 microseconds all the way up to 100 milliseconds. So ideally, in the ideal world, you want all of your IOs to have latency as close to 100 microseconds as possible. So the ideal shape of this graph is all the weight of that graph is down at the bottom. Okay? Now, in reality, that's not going to happen because of all kinds of various reasons why, and I mentioned a couple of them, block size perhaps, the sequentiality, that's not going to happen. But if you look at your stats today and you see 10 milliseconds of average latency, and the client is on the phone with you saying, I am seeing high latency, this is not appropriate, what's going on? And you look at your dashboard, and you look at your storage element manager, and you see 10 milliseconds of latency, and you say, problem is not storage, problem is you, right? Well, how do you know that it's not your problem? Because maybe that 10 milliseconds of latency, which is the average latency shown by all of your storage array tools, and all of the other virtualization tools, maybe that is accurate at 10 milliseconds, but maybe a whole bunch of I/O is actually finishing at 100 milliseconds, but it's just getting averaged down to 10 milliseconds. The worst example of that I saw was a case where there was TCP packet drop going on because the iSCSI traffic had been routed on the wrong network. And so without even thinking, the switch was dropping 20% of the traffic, right? And the average I latency was fine, but actually transactions were timing out. There was crashes happening. There was things just falling off, right? Because storage traffic, you don't expect a lot of retransmissions on the underlying subsystem. So the result of all of this was complete lack of knowledge about what's going on. So I got called in, I said, run VSCSI stats, and then after hours and hours of these admins trying to solve the problem, in 10 seconds we solved the problem, because what we saw was a curve like that, except it had a big bulge at the top and the bulge at the bottom. And the average of that was working out to be that approximately 10 milliseconds in that case, and you would have never found this problem, or perhaps you would have, but it would have taken you hours and hours, maybe days, to find that the routing of an iSCSI was the problem, right? So again, being able to see the distribution of the IOs in terms of the latency, what percentage of my IOs are seeing what type of latency in any given time period, is the power of VSCSI stats, okay? So VSCSI stats became quite popular around 2009, 2010 timeframe, and I think people are just starting to forget about it, so I wanted to bring that back to our attention now. Okay. Another tool, very recent tool, but very cool tool that I want you guys to go look at. This is a new company called Arkin. And what they've done is that in the world of NSX or ACI, in the world where there's an overlay network, there's a gap between overlays and underlays. So there's a gap in not being able to know where the problems are, what the disconnect is. So connecting your NSX to your Cisco, right, there's a huge gap. So what Arkin has done, so it's not just pretty graph, it's actually have really cool technology underneath to actually connect the two worlds and to help you find problems. So they're actually demoing today as well at the show floor. Really cool technology. I think it's worthwhile looking at, because as server admins, as VMware admins, we're starting to take on more responsibilities, and you do have to look at network problems as well. So in the world of NSX, this is quite valuable, definitely worth looking at. So another thing, starting to, it's maybe not the most sexy thing, but on a day-to-day basis, it really gives you a lot of power, and that's why I included it in the Unofficial VCDX Toolchest here, is something as simple as inventory analytics. Now, when we think inventory, right, you don't think VCDX. You don't think, something that's going to give you a lot of power. It's inventory, right? It's, it's just tracking things. But actually, if you do inventory analytics, there's actually really, really interesting things that can come out of it. So I've got a couple of examples here. So one of them is the hardware inventory. That's the one on the bottom. Looking at the hardware inventory and running analytics on top of that allows you to see, for instance, whether you have components in your servers that would disallow that server to be upgraded to a new version of ESX because of some driver incompatibility or some other reason why VMware or that vendor has dropped support for the new hypervisor for that piece of hardware. Now, who would have thunk it, right? Inventory. But if you do analytics on top of it, really, really interesting things come out. Another thing, we always have inventory projects about the types of operating systems that we're running on top of our VMware environment, right? But if you do analytics on top of that, now you can start to plan ahead and notice that, hey, I've got, in this case, 31 virtual machines that are within 6 months going to come up for end of support based on the operating system versions and when the vendor of the operating system has declared end of life and end of support for those products. Something as simple as inventory, but you do analytics on top of it, and you can become proactive in your management. And finally, if you took the inventory of the virtual machines that are running in your environment and you did something as simple as, hey, I want to take a subset of those, a subset of my virtual machine inventory, and I want to do a what-if analysis of putting that up into a cloud service. So for example, in this case, in the example on the top left here, the VMware vCloud Air service. And of course, this can be done for any service. But just something as simple as analyzing your inventory to do a what-if analysis like this enables you to try to figure out, well, how is my internal IT running in terms of cost to be able to run those virtual machines? Because now I can compare them to AWS or to vCloud Air. Now, that cost comparison, again, is an inventory use case, but being able to analytics on it, gets you pretty far. So encourage you guys to take a quick look at the whole world of inventory analytics and what that can enable for your businesses and teams in terms of becoming more proactive, spending less time in reactive management, as well as in saving cost. Speaking of saving cost, here's a cost that almost every single environment that my team has looked at in terms of optimizing those environments, almost every single one, even the ones where the admins were most proud because they had the cleanest environment, we almost always find orphan VM disks. And so there's times where there are terabytes and terabytes and terabytes of space being wasted because there are these virtual disks that have no links to anywhere, and they're just hidden from every tool, almost every tool, except this one. And they're just wasting space and taking up space. So looking at orphan VM files is a very cool, very simple little tool that you can run and belongs in your tool chest. Now, VMMark, another thing that VMware created many, many years back and is now at version 2.5. Again, when it came out, a lot of submissions happened, and now I think there's about 200 submissions that have happened for different types of hardware on top of this. Now, this is more focused on compute, but also has some I/O components. It's kind of a balanced workload. So VMMark is a virtualization platform benchmark, and what it's doing is taking some workloads that are typical that run on top of VMware, formalizing them, and running them in a systematic way to get results. So I think this is one of the things, again, that is highly useful when you want to generate workloads in your environment. Today, you might be looking at Iometer or other memory stress workloads. Well, here's a really, really interesting workload that you can run and leave running for a while to test out the new cluster that you're looking at, or if you're doing a proof of concept. VMIO contentions. Now, the classic way of looking at storage performance is to look at charts, to look at latency. And we've already talked about how latency is not really necessarily the best metric to look at, although we always think latency is better than IOPS. Well, it is, but it can fool you unless you have access to something like vSCSI stats. But beyond that, there's another problem with looking at just latency, and that is that if you're experiencing high latency, you don't know if that's your workload or another workload. So looking at VMIO contentions actually helps you because it automatically figures out which workload is at fault, and those are called culprit VMs, and which ones are actually experiencing the problems, and those are called victims. So that culprit-victim analysis, being able to do that very quick, is a strong suit of this tool. So finally, I want to end with, this is you, this is us. We are running our enterprises. We are the reasons why our data centers are staying up. So as vAdmins, we are like commercial airline pilots. We're like fighter jet pilots. We have these really complicated systems that we have to constantly understand. We build these dashboards to be able to constantly understand them and manage them and keep them up and keep them healthy and keep them flying in a very, very efficient way. So we are like this pilot, okay? And what we need are tools that we deserve, the type of tools that you'd expect a pilot to be able to receive when he enters a jetliner, right? So we would really have to work hard as a community and as an industry to get our tools to be at the level that you'd expect in a modern commercial airline. Thank you.